All right, in this video, we're gonna learn how to calculate hash of a file. So what the hell is a hash? Hashing a file means running the file's contents through a mathematical function to produce a short unique fingerprint. So we take a movie MP4, we run it through some function, and we get some sort of like a string. So that's the SHA-256 hash. So every hash is probably unique to every file, I think. If even one byte changes, the hash changes completely. So we have like two almost identical files, but only one byte is kind of changed. Then the hash itself is very different. So hashes are used to downloads verify downloads aren't corrupted, detect duplicate files, check if a file was modified. Integrity security checks. So hashes are like file's fingerprint. Two identical files will have the same hash. Different files almost always have different hashes. So let's try to learn how to hash a file. So first let's try to learn how to get the SHA-256 hash. The most common way in Go is to use crypto packages and stream the file into the hash. So we need to get hold of the file. You can use the open method or something. And then we need to use the SHA-256 package and create a new hash. And then we need to copy the hash to the file. Okay. Input, output, destination. This is weird. So this is the destination. I think this is the source. So it's kind of like copying the file to hash or something. So you need to do all this complicated stuff just to get the hash value. Okay, first let's open up a file. Okay, OS open. So this is a 17 minutes file. Let's see if it. Okay, we need to use this SHA package, and this gives us a hash or something. And then we need to use the IO copy hash file. Um, and then we need to call hash sum. So what does this do? Sum appends the current hash to B and returns the resulting slice. It does not change the underlying hash state. What is it? Okay, so this gives us some like sum or something. So what's the value? We get a byte. Man, running this every time is gonna be very long, I think. So this is a byte. I don't even know, like, can we convert the byte to string? Okay. So when it was pretty fast. When we convert the sum to string, we get some garbage value. So we need to use X package and encode to string. All right, so this is the encoded string. So there's, okay, first of all, what is this? Okay, I get it. This gives us some sort of like a empty as or something, and we are just copying the file to this as. So what is this whole process doing? Okay, so when we call new, creates a SHA-256 as calculator, um, waiting for data, reads the file and feeds its bytes to the SHA-256 machine. So conceptually, all our file bytes goes to the SHA calculator. Okay, the reason we were able to use the copy method on it because as implements IO writer, so IO copy keeps doing something like so this the default or whatever implementation. So it's gonna just keep on feeding the bytes by using chunk internally. So what does this sum do? Okay, what's the final SHA 256 digest? So it gives us some byte. So bytes are some goofy looking values, raw binary bytes, converts those ugly bytes into human readable hexadecimal. So, so this is just a hexadecimal, which is the as people normally use. So we are using IO copy because we don't want to put the whole file in the RAM. IO copy just feeds the as machine thingy um, like a little bit at a time. Why do I get random garbage when I convert it to string? Of so because it returns byte of raw binary data, not text. If you do go just interpret those bytes as UTF-8 characters, becomes something like random garbage. That's because those bytes represent, which are as bytes, not letters. Think of like this, something like works. So this is normal text byte works because those bytes happen to be ASCII text, but as SHA as is basically random bytes. Those don't correspond to printable characters, and that's why people do. Uh, they just convert it to X. Every byte becomes 2x characters. Does the same thing. Most Go code users either convert it to X or use this goofy as format specifier syntax. Let's do that. So use the format specifier thingy and use the x value and then sum. Okay, that's the same thing. Okay, I rewrote it so that I can read the directory and get all the files. So this is the directory I want to get all the files from. I'm not doing anything new here. I'm just reading the directory, getting the entries, looping over the entries and getting entry. And I'm checking if the entry is regular. And if it's a regular file, I'm just opening it and I get the file. And then I do the same thing. I create the empty as machine thingy. And then I copy the file to the as. And then I sum, and then I print the and then I convert the sum to x representation, hexadecimal or whatever. And this is pretty fast. So this is the as value for this file, some garbage value, and then notice I have purposefully created a duplicate of this file, and their asses match. So that's how we know we got a duplicate file. Okay, there are two more ashes you can generate. One is MD5. This is fast, but it's not secure. This is good for duplicate file detection. And then there is SHA1. So it's the same process. You just use the different package. So we are using SHA256 package, but if you want to use MD5, SHA1, we just need to replace this part with those packages. That's pretty much it. So let's just create something like this. I'm gonna just only replace this part. So if you want to do MD5, we just need to replace it. Wait a minute. Okay, that's the wrong place. Oh, here. Just need to replace it with MD5. So just replace everything with MD5. So if you want to do the same thing with SHA1, same thing. SHA1 as SHA1 as some nil. All right, let's try running this. So these are the assets generated by SHA 256. This is MD5. This is SHA1. Now let's look at the downside of using these three um, algorithms generating assets or something. So of all these three, SHA-256 is the most secure and doesn't contain collisions, right? Both of these, MD5 and SHA5, as observed to be to contain collisions. So for normal file duplication detection, these three are fine. But if you want to use it for security, integrity or whatever, don't even bother with MD5, SHA1. So the biggest downside of using this is that we need to read every byte so we can add it to ACID. So this is a very IO very heavy IO operation. And it probably wears your SSD out, I think. Anyway, so the goal I'm trying to achieve is I'm trying to find duplicate files. MD5 is pretty fast. All of them are pretty fast, and on my 17-minute video, but I don't want to use this. I don't want to copy a file. So instead, what I'm gonna do is just look at the size of file, and if two files have the identical sizes, I'm gonna declare them as duplicates, possible duplicates, and I'm gonna leave the user to decide whether what to do with those duplicate files. So let's first try to get the file sizes. It's pretty easy, right? We just need to use the info method. All right, I got a path to get the stats. I can use the OS stat, I think, and open, give it the path, and I get file info and error, which I'm gonna ignore. Let's just print the info object. Let's see what we get. So it doesn't really give us anything like. So let's get the size. So this is the size in bytes. So look at the size. I think this is pretty unique, right? There's no way like so many files could have the same byte structure or whatever. So that's why I think it's the best idea to just group similar files with the same sizes. So now we just need to group. We just need a way to crawl all our directory and group the files by the size. Okay, to group, we're gonna use the map. The keys will be of the type integer 64, and the values will be strings. So to group it, all we need to do is just assign the size and path to the size key, right? So if I have the size, let's say I'll just call this size real quick. Also create a map, size map. So this as a type How do I even create, bruh? Create a map. Okay, we need to use a map and int 64, and it will string value. So size map, we assign the size. So remember, the size will be the integers, and then it's gonna be just for strings. Okay, what is this? We're appending the path. Okay, why can't I just do like this? Okay, what's wrong with this? Nothing is syntactically wrong. The problem is probably your goal, which means size is equal to one file path. So, okay, it's just gonna replace it. It's just gonna replace it because the second assignment over the first one. So for grouping files by size, you usually want, okay, so it's just it holds array of string. So yeah, we need to change it to array of string, and then get the size map. So we need to use the append method, append function, and pass the path. Okay, there we go. So we created a map that takes integer 64 as key and stores array of strings, and we get the size, and we take it as the key, and we append to that key all the paths. So there we go. So this is the key and this is the path. So now all we need to do, like wait a minute. So this is the map, right? If we loop over it, maybe like somehow print all the contents of the map, we should see all the duplicates. Okay, I'm gonna just borrow my worker pool single dispatcher bullshit code. So this code essentially just goes through the drive or folder, whatever you uh, give it at the beginning, and finds the folders and all the files, all the regular files. I'm gonna use this to do the same thing, to kind of group it. So the nice thing about this is I can get all the regular files or any files with any type of extension I want. So I'm gonna create files channels. This was a string. So here, if you're not familiar with this code, I'm gonna link the video where I go through this code and explain everything. So this block of code is where we are like we know that this is the regular file, right? I'm just counting the regular file or whatever. So we got all of the regular file. So I'm just gonna send the regular file to the file channel. So now we need to loop over the regular channel, and we need to close the regular channel when we are done. So close the file channel. I mean, we don't need nothing. We don't need anything fancy. I'm just gonna use the for loop to arrange our file channel. So now that we have the full path, let's just try to print the files. We're gonna get all sorts of files. We probably want to limit it to MP files with MP4 extension or any other video extension. So we can do that in this condition. So file path as a I think an extension method that gives me the extension of any like file. So file name, you just give it the file name and it's going to give me the extension. So I'm going to use the MP4 here. Okay. God damn it, I'm running out of space. Okay, there we go. So the condition is pretty simple. Is the entry regular file? Is the entry end with .mp4? If it is, we're gonna just push it to file channel, and then we loop over the file channel, and here we're pretty much sure it's a video file. I'm just trying to find duplicate videos. You can like do whatever you want uh, in here. So let me try to find duplicate files. Again, we just need to open it. We don't even need to open it. We can just use the OS stat and pass the file path. Okay, where is it? So this is gonna give us info and error. Quickly handle the error. Error getting the stats of the file. And then we just skip this loop. Cannot use file path. Type in as a string value in the argument. Okay. How about now? So the file path, the file channel somehow returning some sort of rune instead of string. So yeah, we're pushing string, fine, but why? Why is this some sort of like rune or something? Okay, what is this? All right. So I had a weird syntax. All right. Now we have the info object. We need to yeah, pretty much like we are creating the size map. I probably want to create it outside of the loop. I get the size, I put the size to the map, append the path. Okay, like file path. Okay, now pretty much like we have the the map, but we need to display it neatly. Okay, so this part of the code runs when we have processed every folder. So this is like the last like block of code that runs. Although we could have like used a variable like, let's say, is done set to false and use it here. And then this is the last part of the code that runs and set is done to true. Then after end of this loop, we can do whatever we want at the end, right? So we have size map. We can range over it. When we range over it, we get key and the value. The key is size, the value is the file paths. So yeah, I'm just gonna call it files range over size. Okay, what is this syntax? Okay, I need to use the for loop. Then we can just print the size. The size is size, and then files. These are like array of strings, so we can loop over them. Again, we get file item, file. Maybe calling this is files, maybe better idea. And then we just print file item. All right, seems good enough. Let's try running this. Although it's kind of like I have removed this part of the code that kind of tells me when we discover folder. So let me put it back. So it only our files, I feel like. So where is the channel? although we can react to the incoming files, here we can get the files as soon as we receive it. We can just run OSStat, process them. We can add it to the map. But if we want to like print the whole thing, we need to wait for the whole process to be over. Let's see if it nope, we got some error. So where is the error? At line 50. I feel like when we like, yeah, I think we need to put this at the top. So this is gonna just block whenever like we send it. We probably want to also run this like independently, because it's gonna also block this is also gonna block uh, since it's a buffer channel. Okay, so I moved at the top and I launched it with go routine. We don't need to track this go routine to end or something, because I'm just using the channels, and I'm gonna close the I'm using channels with for loop, and then I'm gonna eventually close the channel, so the for loop's gonna just exit. Also, I made a very nasty mistake here. So this is just the index. This is the path and this is the index. I'm just printing index, bro. Look at this. Look at this goofy. Okay, let's run it again. All right, there we go. We got although we probably don't want to print like files that only has one value in the key, in the key, right? So we got the size map files, and we don't even want to we only want to loop over it if the files, like let's go to length, files length is greater than like 1. Greater than 1. Is this greater than 1? Also, another mistake is putting this at the top, bruh. So that just did this goofy thingy. All right, finally, we got it. We got it working. So we got the size and duplicate files. Look at this. We got a duplicate file on two different folders. One is on 25 folder and one is on 26. So the next thing you probably want to do is sort this map, by the size. So the larger files appears at the top and the smaller at the bottom. I'm not going to do that now. So that's pretty much how you can find the duplicate files. If you're a mad lad, you could use the aliasing algorithms I showed you earlier. That's pretty much it. I'll leave the source code in the description. I found a couple of issues. So the first issue is here. We are closing the file channel, right? So I assumed when I close the file channel, the go routine will be like finished. So let's see. Okay, so this is the go routine that is looping over file channel. So when I close the file channel, it should it should be in the middle of processing the previous files and shit. Although it's gonna be like only one. It's gonna be like only one file that may be in the like incomplete when I close the file channel. It's probably it's not a big deal, but this is not properly being like completed. So if we really want to make sure this is completed before I loop over the size map, I probably need to wait for this go routine to complete. Again, we need to use the classic the wait group. So we're just tracking this one specific go routine. There's nothing special, just wait for this go routine to complete. And then at the end of this and at the end of here, we probably want to wait for that before we call the size map. Also, we are using the OSStat and the file path, but when we do reader, the entries I get already has a info object, already has a info. So we could probably push the info object to the file channel and then just get on with it. Also just get rid of this old thing and just process the info, right? So we got the info. So where is it? We could probably we don't even probably need this coroutine. How we are interested in the file. So where is it? So we got the size map declared here. So we can get hold of that size map and just copy and move it here. So entry info size. Okay. Entry info, it returns a info object and error. So if we got an error, so we're just gonna print something. Error getting the file info, and that's pretty much it. So we got the info, and let's get our size, info, size, and also file path. Okay, full path. That's supposed to be full path. So now we can just get rid of this whole go routine bullshit. There is no file channel now, so we don't need this. So let's just get rid of the file channel. So no error so far, I think. So now, when does this whole thing finish? When is it okay to call this size map? So when this for loop exits, we're pretty much done processing everything. So this, I'm fine running this. Okay, now we're getting concurrent read write error. Where is it? Okay, concurrent map writes. So we probably need to use the mutex here. I'm just gonna quickly add it. Again, we just need to create a type a struct. We have done this in the past. So this is the safe map, and this needs a mutex. I think sync mutex, and then it needs the map. So where is it? Let's call this safe map. Okay. So we have the safe map, and here let's initialize it with some empty garbage. So now every time we call append it, a safe map, okay, size map as mutex lock size map mutex unlock. So yeah, this whole code is protected. Size map and safe map. Okay, let's see if it works. Cannot range over size map variable obstruct. Okay, and then let's see. Okay, this should be enough. Okay, not enough. Panic assignment to entry in a nil map. Assignment to entry in nil map. Okay, so we have a nil map. So this is right. So let me just do something like this. Maybe this will work. Nope. Panic assignment to entry in nil map. Okay, I'm gonna ask ChatGPT, bro. Your mutex is fine. The map itself is nil. Then this creates size map nil equal to which is a nil map. Then later append, because Go can't insert into a nil map, initialize it. Bruh. So this is just one of Go's weird quirk. We need to initialize the map inside the safe map struct. So this just creates a map or something. All right, it works. Let's see if we have any problem. Is this good? It's much better for, I say it's good. The architecture makes sense. Check error before using info. Okay. So we just need to check some error. So where is it? And then yeah, we just need to continue. Do we need to skip this whole loop just because we find a regular file? I guess. So we check the info. If we have error, we continue. Otherwise, we okay. So I am reading the map without using lock, without using mutex at the end. Although it's fine because we are pretty much done with the processing folder and nothing is reading it. But I guess we need to probably use this at the end. All right, so this is pretty good implementation. Again, the source code will be in the description. See if we can improve anything here. So we got results, safe map, jobs, file counter, pending workers, messages, range, looping over garbage. Although I probably want to rename the size map to something else. See if it works one more time. All right, guys, we learned how to find duplicate files. Although it's a bit of a guesswork. It's not exactly finding duplicate files. It's good enough most of the time. So pretty cool. That's pretty much it for this video. I'll see you in the next video.